for Societal Sustainability and Climate Change Mitigation, conducting by Mechanical Engineering Department, Lakiriti Valreti College of Engineering. The Department of Mechanical Engineering has been in existence ever since the college had its inception in 1998. The department offers BTech in Mechanical Engineering and MTech in Thermal Engineering. The BTech program had its initiation in the year 1998 and the present intake of students is 60. The MTech program is initiated in the year 2010 and the present intake is 6. The BTech program is accredited by National Board of Accreditation NBA from 2008 and Institute's autonomous status is approved from 2010 to till date. The department has good infrastructure in terms of state-of-art laboratories, workshops, and computer centers, innovation labs as required for UG and PG programs. The department has sponsored projects worth of rupees 1.5 crores to its credit, funded by various government organizations. The department have total faculty of 27 with 15 doctorates and various research laboratories including Dassault Systems 3D Experience Center, Applied Robot Control Labs, ANSYS Skill Development Center, along with active participations in NPTEL and many global certifications. The department have more than 250 number of quality publications with H index of 25 numbers, citations of more than 3000. And the department is also have active participation in history student chapter, and also recently ASME student chapter is also active. Now I request Dr. P. Vijay Kumar sir, Professor of Mechanical Engineering Department, to give the opening remarks of this FDP program. Welcome, sir.
Thank you, madam. Good evening and hearty welcome to this 6-day online faculty development program on emerging green hydrogen energy technologies for societal sustainability and climate change mitigation, which was sponsored by All India's AICTE New Delhi, Government of India. ATAL Wing has sponsored this particular FDP to our college. I would like to thank AICTE and ATAL Wing for sponsoring this program to our college. When we applied, we have some ambiguity, but our proposal could go through the scrutiny as well as final selection also possible because of the efforts made by our team. Thank you. I thank AICTE team, entire AICTE team. And coming to the program, I would like to read some numbers of participants which have joined this ATAL FDP all over India. From AP, 114 participants are there. Bihar 5, Gujarat 5, Haryana 1, Jammu Kashmir 2, Jharkhand 18, Karnataka State 7, Kerala 11, Maharashtra 10, Odisha 5, Puducherry 1, Rajasthan 1, Tamil Nadu 23, Telangana 19, Uttar Pradesh 4, and West Bengal 1. So total altogether 227 participants have registered for this FDP, ATAL FDP program. So it shows all 14 major states have covered here. Therefore, it is very good sign of participation of all our fellow Indians who are working in this great country, India. And coming to the profession-wise participation, 214 members from teaching faculty, assistant, associated as a professors, including 17 professors have joined this program. From industry 4 and lab technicians, lab assistants, 3 members joined, and research scholars 5. So this is the brief details of the overall participation of the ATAL FDP all over India. And coming to this program, we have designed this program for green hydrogen energy technologies because the present day scenario okay, fossil fuels, how they are depleting, and in the future, what is the problem for all the human beings as well as industries as well as commercial sector also. So I hope all the participants would take away good um fruits out of this FDP program, as they're going to see expert lectures all through. That means from Monday to Saturday. We have picked up very good expertise members from industry as well as academia, and foreign experts are also there. Total 13 sessions were planned here. So out of 13 sessions, two members are taking two sessions, and that means from India, two faculty members are taking, apart from the regular session, taking one extra session. And also our foreign expert has accepted his consent to deliver two sessions. Is Dr. Balavi Reddy Garu, professor from Canada. This is what about the total overall sessions and experts details. So I would like to thank one and all the participants who have eagerly and enthusiastically and very interestingly registered for the shuttle FD program. Definitely will be uh, benefited, sir, out of this program. I am damn sure. Thank you so much. Thank you, madam. Thank you, one and all. And also, I would
Thank
like to say special thanks to our beloved principal, sir, Dr. K. Apparao, sir, spending his valuable time joined this meeting. And also the today's chief guest, Dr. Anand Shubhiji, sir, senior scientist, who is working in the IISc Bangalore in Center for Sustainable Technologies, who accepted our invitation. Very much thankful to you, sir. And also, as a um, uh, as I asked sir to be as a chief guest, sir also accepted that also. I am very much thankful to you, sir. Thank you so much. Thank you, one and all. Over to you, madam.
thank you, sir. Thank you for the opening remarks. Now I request Dr. MBS Shekhar Reddy, sir, Professor and Head of the Department Mechanical Engineering, to address on this occasion.
Respected Principal Dr. K. Apparao, sir, today's chief guest, as well as resource person Dr. Anand M. Shivapuji Garu, Senior Research Scientist, IISc Bangalore, participants all over the country, deans and HODs of LBRCE, faculty colleagues, good evening. Welcome to you all to this 6-day AICTE sponsored ATAL FTP on emerging green hydrogen energy technologies for societal sustainability and climate change mitigation. Today, we are observing extreme climate conditions, environmental pollution because of exploitation of conventional fuels, nothing but fossil fuels, because of CO2 emission. The present day situation in Delhi, we are observing air quality crossed dangerous levels. Day-to-day life got affected there. The same situation may be there for the entire country in the coming days also. To overcome this, the promising solution is green energy. That is the energy we are getting from the wind, sunlight, or water. In wind power and solar power, India is already doing well. Energy from water in the form of green hydrogen is at the beginning stage, is at the research stage only now. National Green Energy Mission, Green Hydrogen Mission, was established by Indian government in the year 2023 with the aim of India to become energy independent by 2047 and net zero emission by 2070. The recent advancements in terms of high efficiency electrolyzers, hydrogen storage solutions, fuel cell technologies, etc., are making the green hydrogen as a feasible and affordable energy solution. In the journey of green hydrogen as green energy, the mechanical engineer's role is prominent. So let us all contribute for that in the form of introducing courses on green hydrogen in the curriculum and in the form of research publications. I thank the principal sir who constantly encourages in conducting FDPs, workshops, training programs on the latest technologies, and the management for giving the all kind of support for encouraging of FDPs on the present day technologies. I thank all the participants all over the country for joining this program. I once again thank today's chief guest, Dr. Anand M. Shivapuji Garu, for accepting our request and taking the session. Thank you all. Thank you once again. Thank you.
Thank you, sir. Thank you, sir. Now I request our beloved principal, Dr. K. Apparao, sir, to speak on this occasion.
Today's chief guest and resource person, Dr. Anand M. Shivapuji Garu, Senior Research Scientist, Center for Sustainable Technologies, IIS Bangalore, HOD Srikar Reddy Garu, and Coordinator Vijayakumar Garu, faculty members, participants, research scholars, a very good evening to everyone. First of all, I would like to appreciate all the participants for registering FTP program on emerging green and hydrogen energy technologies for societal sustainability and climate change mitigation. Your participation is the key parameter, and your key takeaways from this particular FTP also is the one of the objective of our program. Really, I would like to appreciate the Department of Mechanical Engineering for organizing this particular FTP program. Really, it is one of the good FTP program for one of the burning issue like climate change. So there are many issues are there related to climate change, and for any country to develop energy security is very important. So till now we are depending on fossil fuels, and they are contributing to the air pollution. So we need to conduct research activities on green energy technologies, and hydrogen is one of the prominent solution, because zero emissions is the prominent one out of the various outcomes. So we need to, all the faculty members, it is the responsibility to move forward in this direction, like how to face the challenges of the challenges to utilize the hydrogen as a fuel. Now, at present, in the fuel cell technology and all, hydrogen they're utilizing, and some of the applications we have seen till now. But still, there are many challenges are there, like the volume of the gaseous fuels will be very high. We need to go for the the tank and all. We need to take care of the safety issues also. So all these challenges will be resolved only by research. So in this regard, I'm appreciating all of you for participating in a wonderful FD program. And at the same time, my sincere request is we need to involve our students also in this particular journey, so that they will also get some inputs, and we need to train our students in turn, and while doing their mini project or project work, and we need to do many activities related to teaching learning process, as well as to augment the research activities in the respective departments also. The quality of this FTP already known to the participants by knowing the resource persons. So many IITs were involved, and NIT faculty members involved, and the resource persons like Dr. Bale P. Reddy Garu from Canada, and Dr. Anand M. Shopuji Garu from IIC Bangalore, and so on and so on and so forth. So there and resource persons from industry also. So it is a correct blend of academicians as well as the industry persons involved. So really, I'm very happy that this program is going to help the faculty members and student fraternity also to improve their knowledge as well as skill set in the area of green energies. So one of the prominent area where everybody need to contribute positively for the sake of our to preserve our earth. So this is the one of the important topic. Everybody should have knowledge and skill. So I'm really thanking all the resource persons for accepting our invitation to act as guest speakers for this particular program, especially today's chief guest, Dr. Anandam Shivapuji Garu, Senior Research Scientist, Center for Sustainable Technologies, IIC Bangalore, and we're accepting our invitation as the inaugural chief guest as well as the today's resource person. So I'd like to thank all the participants also for participating in this particular FD program. And my sincere request is participate all the deliberations, even the online program, and try to take the key performance parameters out of this particular program, and try to interact with the resource persons, build the network. That is going to be very important. Collaborative research is important, and for the purpose of collaborative research, also this particular networking, strengthening our networking, academic networking is also uh, also possible with the help of this particular faculty development program. We all need to thank AICTE for sanctioning this FT program, and let us all make it a grand success program after 6 days. So I'm very thankful to each one of. Thank you one and all for giving this opportunity. Thank you one and all. Thank you.
Thank you for your words of appreciation and encouragement, sir. Thank you, sir. Now it's my honor to introduce today's chief guest of this program, Dr. Anand M. Shivapuji, sir, Senior Research Scientist, Indian Institute of Science, Bangalore, to speak few words on this occasion.
Yeah, very good evening. At the outset, sincere thanks to the principal organizers and Professor Vijay Kumar for inviting me as one of the resource persons and also as the chief guest. I also take this opportunity to congratulate the team at Lucky Reddy Bali Reddy College for organizing a very technically important and intense faculty development program. As the Honorable Principal brought out, this is a very burning issue. He rightly put it, it's a burning issue. Climate change is something which is affecting one and all across the globe without favor or favor. So if there are droughts, if there is a heavy rain, so on and so forth, every one of us, every individual gets affected, and there is a pressing need for all of us to come together as scientific community, as human beings, to actually undo the damage that has already been done in the name of science. At this point of time, I would also like to take this opportunity to say a few words about the way modern science has actually contributed to this kind of a climate change, and then why there is a critical need for us to take a relook at the way the science is leading humanity to disaster. If you really look at modern science, or rather I will call it as Western science, not modern science, I will call it as Western science. If you really look at Western science today is taking humanity away from equilibrium. Okay. I'm sure all of you agree that nature has its own way of maintaining some balance. Nature has its own way of maintaining equilibrium, whereas the modern or Western science is today favoring human beings over nature. So if you really look at, let us say, agriculture, modern science has brought up synthetic fertilizers. So because of synthetic fertilizers, what has happened today is we are having excess food that is being grown. And today the population of the world has reached more than 7 billion. Whereas if you really look at natural sustenance of agriculture, then only about 3 billion people can be supported. Okay. So whereas today we are already reaching 7 billion. Similarly, if you really look at medicine as a field, now medicine as a field has also significantly skewed the lifespan of human beings to well above or close to 100 years. Whereas the typical lifespan was somewhere about 60 to 65 years or maybe 70 years. Now, what has this done is it has actually given an unfair advantage to human beings over all other natural beings, including plants and animals. Similarly, there are n number of examples. The underlying essence is Western science, which is only about 200 years old, really does not know where to draw the line, but is always behind economic advantage at the cost of environment. Now, if you really look at our own Indic civilization, ours is a civilization which is more than 5,000 to 10,000 years old. I mean, we really don't know how old we are. The more you keep digging, the more older the civilization gets. And if you really look at our own civilization, always the emphasis was on maintaining harmony with nature, maintaining equilibrium with nature. Today, the Western science misinterprets the Indic civilization attempts at maintaining equilibrium from ignorance. It is not the case. Our own ancestors, our own people from few thousands of years ago really knew all about modern science, but they ensured that that modern science doesn't become reality and disturb the natural harmony. Okay. Having said this, unfortunately, now that we are here, wherein within a span of only 200 years, if you really look at industrial civilization, it started somewhere in the year about 1800, 1850. And today we are somewhere 200 years from there. You can see the extent of havoc the modern science has created. Okay, we are having a lot of problems with rainfalls. We are having a lot of problems with drought. We are having a lot of problems with pollution, so on and so forth. So what is critically needed today is for all the members of the scientific community at national level, at international level, at local level to come together and really focus on re-establishing equilibrium. We need to really understand what is critical for us. Unfortunately, today what is happening is the political system, maybe across the globe, is actually trying to divide people on a variety of topics. But what is the most critical topic is today climate change is threatening the existence of humanity itself. So we should ignore or forget all our differences, whatever they may be, come together as a scientific community and make concrete efforts to actually undo the damage that Western science has done to the environment, try to restore certain semblance of normalcy, ensure that we leave a better future to our generations which come together or come in the future. So with these remarks, I would like to close my opening remarks. Very warm welcome to all the participants to this particular FDP. It's a very important FDP. It will lay a very strong foundation for research in the right direction. So please make use of this particular opportunity that has been created by Lucky Reddy Valireddy College of Engineering. I'm sure after the after these 6 days of intense training through this online mode, all of you will emerge much richer in terms of knowledge base required to fight this climate change. Thank you. Thank you once again. Over
Thank
to
you,
you.
sir, for thank you, sir, for your wonderful words. Now I request Dr. V. Dhanraju, sir, Associate Professor, Mechanical Engineering Department, to give vote of thanks.
Madam, hello.
Sir.
Please call Ravindra Kumar sir if available.
Yeah, sir, sure, sir. Now I request Dr. P. Ravindra Kumar, sir, Professor and in charge head of the department, Mechanical Engineering, to speak few words on this occasion.
Yeah, thank you, madam. Hello.
Sir.
Hello. Am I audible, sir?
Audible, sir.
Yeah. Thank you, madam. Respected principal, sir, respected chief guest, respected dignitaries, respected participants. Hearty warm welcome to this 6-day ATAL FDP online program, especially focusing on green energy technologies, because nowadays this is a the hard issue onto this particular side, especially focusing onto the environmental and clean energy generation point of view. So first of all, I would like to thank organizers and ATAL, the AICTE, for giving sanctioning the FDP program for this particular Lakhireddy College of Engineering. Now here, latest things are that first of all, we should have to get a clarity onto the green energy, clean energy, and another one is the renewable energy. So I think the clean energy is nothing but it creates the no greenhouse gas emissions, whereas the green energy is nothing but no harm to the environment, whereas the renewable energy is nothing but the replenishment of the naturally sources such as solar and wind energy. Then how we can capture the energy from these particular sectors, that is a very great challenge to all generation, all this to this present generation, because already the climate has changed, already environment has much damage has occurred to the environment due to because of fossil fuel usage. Now the latest trends are happening onto the green energy technology side, especially the electrolysis, the hydrogen generation from the ocean technology, how the hydrogen can be generated. Next one is the another important key aspect is that in the mining, especially in the mining side, where the decarbonization, water management, and waste management, how these resources can be utilized very effectively. And especially there are certain key issues, especially the low carbon hydrogen, how that it can be generated, and it is totally cost oriented side. And there is another more technique that we should have to observe is that the carbon dioxide removal process, how there are various latest technologies are entering into the market onto this low carbon dioxide, that is the carbon dioxide removal processes. And another important aspect for this green energy sector side is superconducting magnetic materials. So these are the various important things now we should have to focus on to this particular areas. I think during these 6 days, the participants will get very good knowledge onto this particular program. I think all the resource persons are from the NITs, IITs, and other countries also. So definitely we all get enriched with good information onto this particular program. Thank you, one and all, and thanks for giving me an opportunity to speak a few words. Thank you.
Thank you, sir. Now I request Dr. V. Dhanraju, sir, Associate Professor, Mechanical Engineering Department, to give vote of thanks. It's my pleasure to introduce our first resource person, Dr. Anand M. Shivapuji sir. He is working as Senior Research Scientist in Center for Sustainable Technologies, Indian Institute of Science, Bangalore. He concurred as Founder Director for CAPSUP Solutions Private Limited, Bangalore, Chief Technology Officer for Bharat Train Systems Private Limited, Hyderabad, and Founder Member for E3 Labs Private Limited, Bangalore. Coming to his educational qualifications, he obtained his PhD from Indian Institute of Science, Bangalore, Master of Technology and Bachelor of Engineering from B.V. Bhoomareddy College of Engineering, Hubli. Dr. Anand M. Shivapuji's research areas interests are in production of green hydrogen and green chemicals catalytic synthesis processes, air and oxygen steam gasification of coal and biomass, solid oxide fuel cells and proton exchange membrane fuel cells, internal combustion engines, pressure vacuum swing absorption systems, and he has received honorary diploma from the Indo-Swedish Society in the year 2019, and he received Best Visual Presentation Award at Asian Biomass Conference in the year 2015, and he received Young Researcher Award from Korean Society of Combustion for work on combustion instabilities in non-regular fuel IC engines in the year 2013. He received University second holder in the MTech program. He has industrial experience of 2 years and academic experience of 4 years and research experience of 20 years. He is guiding 15 BTech project students, 10 MTech project students, and 9 PhD scholars. Sir has published 8 national patents, 4 international patents, 35 international journals, 25 international conferences, and 2 book chapters. And now I request our resource person to take over the session.
Yeah. Thank you so very much. Am I audible, please?
Yes, sir, audible, sir.
Okay. Thanks, madam, for the nice introduction. Welcome, one and all, to this particular session. Yeah. Just give me a moment. I will present my screen.
Hello, sir.
Hello.
Sir, meanwhile, we'll have one small, this one's 1 minute. All the participants have to switch on their video, sir.
Okay.
So we have to take a snapshot, sir.
Sure, sure.
So all the participants, please listen for 30 seconds. All of you keep your videos on to take a snapshot with our honorable guest today. Dear participants, please, all of you, switch on the videos. All of you, please. AICTE has made it mandatory, and we have to upload this one as a proof. Okay, thank you. Thank you, all of you. Now we can switch off your videos and we'll go back to our regular session.
Can I continue now, Professor?
Yes, sir. Yes, sir. Please.
Is my slide visible now, please?
Yes, sir. Visible,
Yes,
sir.
sir. Yes, sir.
Okay. Yeah. Very good evening to one and all. I will now take the opportunity to take you all through some slides. Before that, while I have been formally introduced from my side, this is Dr. Anand M. Shivapuji. I am a senior research scientist at Center for Sustainable Technologies, Indian Institute of Science. Audible now, please. Hello.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay. Yeah. Thank you. Indian Institute of Science requires no introduction. It's close to 120 years old. It was started in the year 1908, and it was blessed by Swami Vivekananda. And it started with endowment from the Tata Group, JRD Tata, and the Maharaja of Mysore. Both these great minds came together and established this particular institute. Now, today, I am going to take you all through one very important topic called as representative concentration pathway analysis, which talks about global warming potential of primary energy mix scenarios. Now, the most important thing is in this particular FDP focuses primarily on green hydrogen. Now, in this particular presentation, I would like to lay the context as to why exactly we need to really look at green hydrogen. What are the challenges the global atmosphere and humanity in general is facing, how the scientific community has come together to address this particular problem, and why they are saying that green hydrogen is required. And the most important thing is, if we don't do anything right now, what exactly will happen and where exactly we will land up in terms of the broader destruction of the human society in general. So today, as a part of the first presentation, I will lay the context for the entire FDP, please. Okay. And I would also like to, at this point of time, invite people to actually pose any questions in between itself, so that I will be able to clear the queries as and when it is required. Okay. I am going to the next slide now. Is it visible, please? I am on the next slide. Somebody can
Yes, sir.
confirm.
Visible, sir. Visible,
Okay.
sir. Visible.
Okay. So the first question that comes to our mind is climate change a grand hoax? You might have heard about number of politicians who have been saying that the climate change is not exactly there. It is a hoax which has been promoted by vested interest of scientists, so on and so forth. So today, let us try to understand whether climate change is a hoax, as some political people say, or whether there is a scientific evidence to say that climate change has really taken place and it can threaten the survival of humanity itself. Okay. Now, I am on a slide which talks or which shows a global map, and I will play a small video, please. This is a video of about 35 seconds. And I would like to draw the attention of all the people here to the right side, where the year 1880 to 1884 is written. As I play the video, the year keeps changing, and you can see how the color of the globe also changes. Now here, the most important thing is red color or reddish shade indicates hot temperature and blue shade indicates cooler temperature. Now in the year 1880 or 1884, that is close to 150 years ago, this was how the earth was. Now I will play the video. I hope it is visible to everybody. I'm playing the video now. Can you see the video playing, please?
Yes, sir. Visible, sir.
Yes. So now please also focus on the right top corner where the year is changing. And now you can see earlier it started as blue, and now we can see that everywhere we can see more reddish hints. So we are coming closer to the present date. Okay, the video has ended. Can you see the date 2013 to 2017, please?
Yes, sir.
Okay, now please contrast this with the first slide, the first frame that I was showing, where the earth was almost entirely blue with only small patches of red. Now today what is happening is the earth is almost entirely red with small patches of blue. Now what does that mean is a major portion of earth has, or the major portion of earth's surface has significantly heated up. If you take a look at the left side, top left side of the graph, you can see there is a degree centigrade scale. Blue means negative, red means positive. So you can see, as compared to the global average temperature 150 years ago, today most of the northern hemisphere has heated by more than 2 degrees. And one of the major problem is, if you really look at the North Pole has got heated up significantly. And this heating up of North Pole is a major problem because huge amount of ice chunks there are located and they have now started melting. I will go to the next slide now. Here you can see one more graph which I am showing the North Pole. Okay, you can see the North Pole, please. And if you really look at the year, at the top left, the year is changing, and you can see how the green part, the green shade continues to change. Somewhere in the 1885, the entire black dotted region was covered with ice. But as we are moving closer to the present date, you can see that the ice sheet is significantly reducing. Now, I am moving to the next slide where I am showing some statistics. Okay. The first thing is global temperature rise. Okay. Now, the global average surface temperature has increased by almost 1 degree since the late 19th century. Okay. And 6 of the warmest years on record have taken place between since 2014. That is, since 2014 to 2024, in the span of 10 years, 6 years have been the warmest years since the temperature record has been maintained, and 2016 has been the warmest year till date. Okay. Now, the ocean warming, very important, ocean warming. The oceans have absorbed significant heat, with the top 700 meters of ocean showing a warming of more than 0.24 degrees centigrade since 1969. Now, I'm sure most of you must have heard about something called as El Nino and La Nina. Now, El Nino effect is something which brings monsoon to the Indian subcontinent, whereas La Nina is an effect which actually causes drought in the Indian subcontinent. Now, because of the ocean warming, the El Nino and La Nina phenomena have significantly got altered, and the El Nino effect is now becoming more frequent. Earlier, the El Nino effect was happening once in 10 to 13 years. whereas La Nina, that was the phenomena which brings rain, was continuously sustaining for more than 10 years. So once in 10 years or once in 13 years, we used to have droughts earlier, but now droughts are becoming more and more frequent. Every 2-3 years, once we are facing drought. The last one is shrinking ice sheet. Now, as I was showing in the earlier graph, because of the warming of the northern hemisphere, the northern pole has got significantly heated up, and lot of ice from the northern hemisphere has significantly melted. Okay. Now, if you really look at the northern pole, earlier the northern pole was having a lot of ice. Today, even during thick winters, you don't see a lot of ice there. You only see water. So a lot of ice from the northern hemisphere has actually melted. Similarly, a lot of other changes have taken place, like the glacial retreat has taken place, and because of this, the sea levels are rising and extreme weather conditions are significantly now increasing. Today, if you really look at the weather pattern, I'm sure most of you must have heard yesterday there was a major hurricane in France, and that has left more than 1,000 people dead. Okay. As of today, they have recovered 1,000 bodies, and they say that the body count is still increasing. So as of now, we know 1,000 people have died, whereas the death toll could be much higher. So extreme weather conditions are becoming very, very prominent. Okay, now I am on the slide which talks about climate change causative factors. Okay, what are the factors which are causing the climate change? Okay, this is something which we will dwell upon in this part of the presentation. I am on the slide which talks about greenhouse effect. Somebody can confirm if the slide is moving, please.
Yes, sir.
Okay, good. Now, I'm on the slide which presents the greenhouse effect. Now, just to give a quick overview of what exactly this greenhouse effect is, our Earth, the surface of the Earth is covered by a layer of atmosphere or a layer of gases, which we actually call it as atmosphere. Okay. The prominent gases which are present in the atmosphere are nitrogen, oxygen, carbon dioxide, argon, so on and so forth. These are some of the major gases which are present. Now, one of the important things about the atmospheric gases is that there are some gases like carbon dioxide which are present, which have a very special property. What is this special property of carbon dioxide? Now, the special property of carbon dioxide is that this gas is transparent to radiation of particular frequency, but it absorbs radiation of certain frequency. Okay. Now, what exactly is this? This basically means that the sunlight, whatever is coming from the sun ray, whatever is coming from the sun, which is actually high frequency radiation or short wavelength radiation, is directly coming into the atmosphere, onto the Earth's surface. Now, as the sunlight comes into the atmosphere, through the atmosphere to the Earth's surface, it heats up the Earth's surface. Now, I'm sure all of you are aware that any body which is above 0 Kelvin emits radiation. Okay, only bodies which are at 0 Kelvin do not emit radiation, but any other body, even if it is at 1 Kelvin, they emit radiation. Now, the surface of the Earth typically, the average surface of the Earth is 15 degrees. So, surface of the Earth gives out some radiation back into the atmosphere. Okay, sunlight comes from sun to the Earth. Earth gets heated up, and the Earth surface gives back some radiation. Now, this radiation, whatever is given by the Earth's surface, is what is called as a low frequency or long wavelength radiation. Okay, I repeat here, the radiation coming from sun is high frequency radiation, whereas the radiation that is given out by the Earth, which is colder than sun, is a low frequency or long wavelength radiation. Okay, now The carbon dioxide, whatever is present in the atmosphere, has got a special property of absorbing all the radiation given out by the earth. That is, it absorbs the radiation which is having a long wavelength, whereas it does not absorb any radiation that is having short wavelength. Now, what exactly happens because of this is the radiation that is given out by the earth is absorbed by the carbon dioxide present in the atmosphere, and because of this, the atmosphere starts heating up. Okay, the atmosphere starts heating up. Now, this is what is called as greenhouse effect. Carbon dioxide, whatever is present in atmosphere, will absorb the radiation that is given out by the earth, and it starts heating up the atmosphere. It is like wearing a blanket during cold season. Now, this exactly is what is greenhouse effect. Now, before going further, I would like to discuss a little bit about this graph on energy use pattern, and then again come back to the greenhouse effect. Okay. Right now we have understood the fact that carbon dioxide present in the atmosphere will absorb the energy or radiation given out by the atmosphere, and it will lead to warming of the atmosphere. Okay, that is something which is now understood. Now, before discussing further, let us please look at the energy use pattern. In this graph, you can see that somewhere before 1880, okay, the primary energy use was only wood. Okay, no other energy was being used earlier. Okay, this is very common knowledge, because all our ancestors used to make use of wood as the primary source of energy. But look at what has happened after 1880. Okay, that is the period where industrial revolution took place. One of the major thing that has happened is the use of biomass or wood has come down, whereas the use of coal, petroleum, and natural gas has significantly increased. Okay. Now, below the graph, I have given some numbers. Here you can see that pre-industrial revolution era was dominated by wood or biomass. Okay. At the peak of 4 exajoules per annum energy, 270 million tons of wood was used. Okay, that is somewhere in the year 1880, almost 4 exajoules of energy was being generated by burning of wood. That means you require 217 million tons of wood for providing the energy. Okay. Now, every kg of biomass or wood that we burn gives out 1.9 kg of carbon dioxide. Okay. Sorry. The total carbon dioxide emitted was 513 metric ton of carbon dioxide equivalent. That is almost twice. You can see 217 to 2 approximately. That was the amount of carbon dioxide that was emitted. Okay. Now, if you really look at the atmospheric carbon dioxide, if you take away the activity of human beings, then carbon dioxide exchange by nature takes place in two ways. One is ocean. Okay. I'm sure people are aware here that oceans are the major source of carbon dioxide release as well as carbon dioxide consumption from atmosphere. Okay. Now here, if you see, ocean every year gives out 332 gigatons of carbon dioxide, whereas it consumes 338 gigatons of carbon dioxide through various means. Okay. The beauty is it is giving out 332, but it is consuming 338. That means it is naturally consuming 6 tons, 6 gigatons extra. Okay. So ocean is acting like a natural source of consuming carbon dioxide from the atmosphere. Now, the next major source of carbon dioxide exchange is biomass, okay, or trees. Here you can see the land and the vegetation give out 439 gigatons of carbon dioxide, whereas they consume 450 gigatons of carbon dioxide. Okay, so you can see almost 11 gigatons of carbon dioxide positive consumption is there because of trees. Now, if you leave nature on its own, you can see that every year 11 plus 6, that is almost 17 gigatons of carbon dioxide will be consumed by the atmosphere. okay, or consumed by the nature. Now, yeah, I wish to draw your attention to the previous slide. We said that by burning biomass earlier, we were releasing 0.5 gigatons of 0.5 gigatons of carbon dioxide into the atmosphere, okay, every year. Now here you can see nature is consuming 17 gigatons and a human being was giving out 0.5 gigatons. So there was no problem at all before 1880, okay, because nature was consuming more carbon dioxide than human being was giving out carbon dioxide by burning biomass. Okay. Now the problem is after 1880, what exactly happened was, as I showed earlier, the consumption of the consumption of fossilized carbon became very high. Fossilized carbon is the carbon that was generated over millions of years of processing biomass, which got converted into something like coal, which got converted into something like carbon rich liquid fuels, carbon rich gaseous fuels, so on and so forth. Okay. Now after 1880, because carbon based fuel consumption became very heavy, what happened was carbon imbalance got introduced. Now here you can see in this particular graph, the bottommost region up to about 5 terawatt hours, you can see there was traditional biofuel, but over and above you can see coal, crude oil, natural gas, so on and so forth being consumed in a very large quantity. Okay. Now the carbon dioxide that is emitted because of human activity is called as anthropogenic carbon dioxide emission. Okay. It is called as anthropogenic carbon dioxide emission. Now, in this graph, where I am talking about anthropogenic carbon dioxide emission, here you can see that year on year, as the economy of the world has grown, the anthropogenic carbon dioxide emission has grown significantly. Okay, you can see as we have come closer to 2018, the carbon dioxide emission has grown from 20-25 gigatons to almost 40 gigatons. So that is almost 100% increase. Now, what does this mean in terms of carbon dioxide in the atmosphere? Okay. Now, I would like to draw your attention to this graph where I am talking about carbon dioxide levels in the atmosphere. Okay. Very interestingly, the carbon dioxide levels have been measured for the past 8 lakh years. Okay, of course, maybe during that time we did not have direct instruments to measure, but based on ice sheets as well as measurements in deep ocean and measurements in deep mines, the typical carbon dioxide levels since 8 lakh years have been measured. Okay. Now, as you can see in this graph, somewhere 8 lakh years ago, the average carbon dioxide that was present in atmosphere was 200 parts per million. Okay, 200 parts per million. Okay, now just to give you a comparative analysis, 1% is 10,000 parts per million. Okay, here you can see it is only 200 million. So that effectively means it is somewhere 0.002%. Okay, now if you look at the way carbon dioxide in the atmosphere has been varying, till human beings came, the carbon dioxide in the atmosphere was varying somewhere between 200 and 300 ppm, not more than that, 200 and 300 ppm. Cyclically, it was varying, and cyclically, we also used to get some ice ages because of this particular variation. Okay. Now, you please come to the right side of the graph, wherein you can say, after emergence of Homo sapiens, Homo sapiens is basically human beings. Okay. After emergence of Homo sapiens and after the Industrial Revolution, you can see a sharp rise in the carbon dioxide in the atmosphere. What was there as less than 300 ppm has suddenly become more than 415 parts per million. Okay, understood? Whatever was earlier less than 300 ppm for more than 8 lakh years, today it has suddenly become more than 415 ppm. Now, what is the consequence of this? In this graph, I am showing the consequence of this. Okay. Now, this is the global temperature variation because of the anthropogenic carbon dioxide emission. Okay, now, if you really look at the year 1860 and around that particular range, here you can see that most of the time the temperature was less than 15 degrees. Okay. Okay. Another important thing is 15.08 degrees is taken as the average reference temperature for consideration. So the reference temperature is always 15.08 degrees. This is the atmospheric temperature. Okay, this is the average atmospheric temperature. Anything above or below this is what is because of the global warming effect. Okay, anything above or below this is due to global warming. Now, here, if you really look at the temperature, you can see that earlier the temperature was predominantly less than 15.08 degrees, but as we are coming closer to the present day, as we are coming closer to the present day, the temperature is continuously on the higher side. If I can draw your attention to the graph from 1980 and beyond, you can see that the temperature is always on the positive side. It is always higher than 15.08 degrees. Now, this is attributed to the continuous increase in the carbon dioxide levels of the atmosphere. This is something which is very important. Now, I am in the next graph. Has the slides moved, please? Somebody can confirm. I am now talking about a different graph wherein I am showing the variation of, on the x-axis, I am showing the year. On the y-axis, on the left side, you can see increase in temperature. On the left y-axis, I am showing increase in temperature, and on the right y-axis, I am showing the parts per million of carbon dioxide. Okay. Now, there are two graphs. One is the yellow line, which talks about carbon dioxide in the atmosphere. The other one is orange line, which talks about the atmospheric temperature. Okay. What is the most interesting observation from this graph? The most interesting observation from this graph is that as the carbon dioxide level increases, the temperature of the atmosphere also has increased. Okay, the temperature of the atmosphere has also increased. Now, why is this important and why are we emphasizing on this? As I was telling earlier, some people have been saying that climate change is a hoax and there is no such thing as climate change. But this particular graph clearly establishes the fact that, this particular graph clearly establishes the fact that if more carbon dioxide is emitted into the atmosphere, then temperature rise will take place. Okay, if more carbon dioxide is emitted into the atmosphere, then continuous temperature rise will take place, and this temperature rise will result in the climate change. So this particular graph is basically the what we call as scientific proof to say that today climate change has taken place and we are attributing the increase in carbon dioxide level in the atmosphere to the climate change. Okay. Now I am in the next slide, an important slide wherein we are seeing the bell curve. The left side you can see there is something called as current climate. Okay, and on the right side you can see something called as future climate. Okay, now this was done some time back. If you really look at the current climate, then you can see it was having more cold region than hot region. But if you see the black color line, there you can see that there are more hot regions than cold regions. Again, this is purely because of the increased carbon dioxide levels in the atmosphere. Okay. Now, what causes this increase in the temperature of the atmosphere? While we already discussed about carbon dioxide and the effect caused by carbon dioxide, it is also important to note that there are many other molecules or there are many other compounds which are more dangerous than carbon dioxide. Some of these things are methane, oxides of nitrogen, fluorocarbons. Okay, these are some things which are more dangerous than carbon dioxide. You can see one molecule of methane is 21 times more dangerous than carbon dioxide. Similarly, nitrogen oxide is 310 times more dangerous than carbon dioxide. Now, the problem is the energy systems that we have today, the energy sources that we have today are all releasing this kind of compounds into the atmosphere. Okay, therefore these kind of gases are also causing more and more climate change. Okay, now these are some things which I gave in perspective, but the question is, has climate change been recognized globally? Okay, if you really look at it, has climate change been recognized globally? Okay, that is the next question that we are going to answer. Now, at some point of time, people started understanding that there is something wrong with our atmosphere. And how did people understand this? They understood because as we were discussing, lot of change in the atmospheric weather started taking place. We started having lot of rains. We started having lot of droughts, so on and so forth. So things were not normal. Now, because things were not normal, there was something, some very adverse weather patterns were taking place. Now, to understand these weather patterns, in the year 1988, the United Nations established what is called as the Intergovernmental Panel on Climate Change, IPCC. Okay, it was Intergovernmental Panel on Climate Change, and it was established in the year 1988, and it is located in a place called as Geneva. This is in Europe. Okay. Now, this particular IPCC was having a mandate of understanding what is happening to our climate and what is the reason for that, and are there methods by which we can actually prevent further degradation of the climate. So this was the mandate of the Intergovernmental Panel on Climate Change. This Intergovernmental Panel on Climate Change had many meetings, many conferences, so on and so forth, to understand how the weather is changing and so on and so forth. And in the year 2015, one very important event took place in Paris. Okay. In the year 2015, there was an important event that took place in Paris. This is called as the 21st session of Conference of Parties. 21st session of Conference of Parties, and this took place from 30th November to 11 December 2015 in Paris. And in this particular conference, some very major outcomes were presented and some very major decisions were communicated. Okay. Now I am on a slide which shows Eiffel Tower. Is it visible, please? Somebody can confirm?
Yes, sir.
Okay, great. I will keep intermittently asking this because in online mode, you never know. Sometimes the slides get stuck. Okay. Now, in the conference of parties that took place in Paris, it was decided that by the year 2100, I would like your attention here, please. By the year 2100, if the temperature of Earth increases by more than 1.5 degrees over the global average. Okay, what is the global average temperature, please? 5.08 degrees. I have already shown this earlier. So if the global average temperature rises by more than 1.5 degrees by the year 2100, today we are only in 2024, please. So by the year 2100, if the global temperature rises by more than 1.5 degrees, then humanity cannot survive. So what the Conference of Parties mentioned is that as a whole, as a humanity, we should restrict the global temperature rise to less than 1.5 degrees by the year 2100. We cannot allow the temperature rise to go beyond 1.5 degrees. Now, as a part of this, there were many decisions were taken, and then many pathways were laid. Okay. Now, these are some pathways which I am just indicating here. Will not dwell much on this. Okay. Now, in this Conference of Parties, 187 countries participated, and there were targets which were given for 400 plus cities. Now, why the targets were given to cities is because, as you are aware, these cities are major centers of energy consumption and hence pollution. So, if cities are targeted, then overall at a global scale, controlling emissions becomes much easier. Similarly, 114 companies were also brought on board, and a total of $1 trillion was committed, okay, for investment in clean tech. So these were some major decisions that were taken in the COP21 in France. And the best part was almost all the countries agreed for this. 146 countries ratified the agreement. See, there are three things that I'm indicating here. One is a ratification, the other one is signature, the third one is not signed and withdrawing. Okay, third one is not signed, withdrawing. Okay. Now, what is the difference between ratification, signature, and then not signing? Not signing is very clear. You are not interested in the protocol at all. You are not interested in the agreement at all. What is signature? Signature is you are interested in the agreement and you are in principle signing on the agreement. Now, what is ratification? Ratification is where the country's decision-making body will ratify or will agree for the decision. Okay. So, for example, in India, the Prime Minister may sign the agreement, but unless it is ratified by the Parliament or unless it is accepted by the Parliament, the signature of the Prime Minister alone will not have any meaning. Okay, but signature of the Prime Minister will lay the path for the agreement to take place. Now, if you really look at the globe, 148 countries have ratified, including India have ratified it. 48 countries have signed, and only 3 countries have not ratified it nor signed it. One is Syria. You must have heard about what is happening in Syria. There is a lot of violence, so there is no government there. Similarly, Nicaragua, there is no government there at all. But the tragedy is even United States of America, which talks big about so many things, is not a party to the Conference of Parties agreement. I mean, what does this mean is the United States is not interested in climate change solution technologies at all. That is why in my opening remarks as chief guest, I told that Western science is the cause or root cause of all the problems, and United States not signing the Conference of Parties agreement is a clear sign that they are not interested in coming up with a solution. They have done a lot of damage, but they are not ready to come up with a solution. Okay. Now, as per the IPCC, and as we have seen also, the target has been set in the sense that we are now clear. We cannot allow the global temperature rise to go beyond 1.5 degrees by the year 2100. Okay. But how do we implement it? Can we even implement it? Is it even practically possible? That is the next set of discussions that we will have in this presentation. Okay. The key questions we are going to answer in that particular in this particular segment is: we have set the target now. How to achieve the target? Okay. What should be the energy mix? Okay. Now, I again draw your attention to one of the earlier graphs where I said that before industrial revolution, we were only making use of wood and then there was no problem. But after industrial revolution, we started making use of lot of coal, lot of oil, so on and so forth, and natural gas, which resulted in a lot of carbon dioxide to be emitted. Okay, and there has been a significant increase in the carbon in the energy use also, because the population has also increased. Okay, so now to cater to the new population, to cater to the increased per capita energy consumption, what should we do? Okay, see, you cannot switch off the light and you cannot switch off electricity to everybody and then say that this is what is going to be the future. The entire human civilization will collapse. Today, what we are required to do is we will have to give electricity and energy to everybody, but we have to give clean and green energy. So now the question is, what should be the energy matrix? How much should be the clean energy? How much should be the nuclear energy? How much should be the coal energy? So on and so forth. And what are the implications on society and what are the implications on economy? Okay, see, today if we can completely switch off all the coal and oil and go to solar, then one of the major things is the cost of energy will shoot up. Okay, so that is an economic implication, so we cannot do that. So there are different such challenges which one needs to address. Now all the questions that I have asked in the previous slide are answered by means of what is called as a numerical model, which gives a pathway for establishing what can be the right energy mix for the future, so that we don't cross 1.5 degrees centigrade as the global average temperature rise by the year 2100. Okay, so some numerical simulations have been carried out, and based on those numerical simulations, some decisions can be taken. Okay, now that is what is called as representative concentration pathway analysis. Okay, so this is what we are going to discuss in the next slide. Now, before we actually discuss about representative concentration pathway, we have to understand a term called as radiative forcing. Okay, there is some term called as radiative forcing. We will try to understand that particular thing, please. Are my slides moving? Are we on the slide understanding radiative forcing, please?
Yes, sir.
Okay, thank you. Okay. Now, what exactly is this radiative forcing? Okay, this is something which we will understand. Now, as I was discussing earlier, in the course of discussion of the global warming effect, we receive energy from the sun, and the earth surface gets heated up, and as it gets heated up, it also gives out some energy. Okay, it gives out some energy, and that energy can go out into the space. Okay, now if all the energy that is coming in is given out by the earth, then we have zero energy accumulation in the atmosphere. So you can see at the top, radiative forcing is incoming energy minus outgoing energy. So if outgoing energy is equal to incoming energy, then the radiative forcing is zero. Okay. However, if incoming energy is more than outgoing energy, then radiative forcing has some positive value. Similarly, if outgoing energy is more than incoming energy, then radiative forcing has got negative value. Basically, radiative forcing is nothing but the difference between incoming energy and the outgoing energy. Okay, incoming energy comes from the sun, outgoing energy goes from the radiation of the earth. Okay, and radiation is the major source of energy that comes in as well as goes out. That is why it is called as radiative forcing. Okay. Again, this is some similar graph. Now, this is an interesting graph that I am presenting here, radiative forcing components. Okay. There are different components which are present in the atmosphere, which can increase the radiative forcing. That is, it can increase the amount of energy that is absorbed into the atmosphere, or it can decrease the amount of energy that is absorbed into the atmosphere. Okay. Now, the blue shaded components are ones which actually reflect most of energy back to the space, and they cause a reduction in the radiative forcing, whereas the orange color components are the ones which cause increase in the radiative forcing by increasing the amount of energy consumed in the atmosphere. Okay, so here you can see, if we look at some of the greenhouse gases, carbon dioxide, methane, nitrogen oxide, so on and so forth, they cause significant increase in the amount of energy that is absorbed into the atmosphere. Therefore, they have a positive radiative forcing. However, if you have some change in the land use pattern, so on and so forth, change in the amount of aerosols that are present in the cloud, then they reduce the amount of energy that is coming into the atmosphere and they reduce the radiative forcing. Okay, now considering 1750 as the baseline year, okay, scientists have told that at that date we will ensure or we will consider the amount of energy coming into the atmosphere and going out of the atmosphere was equal. Okay, so 1750 measurements have indicated the amount of energy going out is equal to the amount of energy that is coming in, and this is measured in terms of watts per square meter. Okay, for every square meter of the earth surface, how much of energy is coming in and going out. Watts per square meter. You can see that in the year 1750 it was 0. Moving from 1750 to 1950, 200 years, it became positive 0.57. Okay, that means every year 0.57 watts per square meter was getting accumulated. From 1950 to 1980, only 30 years, you can see 0.57 became 1.25, more than double. Okay, from 1980 to 2011, okay, only 30 years, it again doubled. Okay, so it is like share market, Indian share market. Every few years it is doubling now. Okay, now that is a very dangerous thing, because I'm sure all of you now understand radiative forcing. If it is positive, it is dangerous because more and more energy is getting accumulated in the atmosphere. Now, what has happened is scientists have come together to understand, or they have come together to build models which show how the global temperature will rise over the next 70-80 years, that is till the year 2100, if the radiative forcing keeps on increasing. Okay, if the radiative forcing keeps on increasing, how will the temperature rise takes place over the next 70-80 years, and what will be the global temperature rise by the year 2100? Okay, please remember, by the year 2100, our global temperature rise should not be more than 1.5 degrees. Okay, that is 15.08 is the baseline. 15.08 plus 1.5, that is 16.58 degrees. Our global average temperature should not be more than 16.58 degrees by the year 2100. Okay, now these radiative force models are what I will discuss now. Scientists have discussed 4 different radiative forced models. Okay, is this slide visible, please? Where I am showing some test tube like structures.
Yes, sir.
Okay, okay, great. Okay, now scientists have come up with 4 different radiative forcing models, which we called as the representative concentration pathway models, RCP models. Okay, now the first one is RCP 2.6, second one is RCP 4.5, RCP 6.0, and RCP 8.5. Now, what is this RCP 2.6? 2.6 is nothing but it is the radiative forcing imposed on the atmosphere. That is, now if 2.6 watts per square meter is the accumulation of energy in the atmosphere, what will happen? Similarly, RCP 4.5 is, if 4.5 watts per square meter gets accumulated in the atmosphere, what will happen? RCP 6 is, what happens if 6 watts per square meter is accumulated, and RCP 8.5 is, what happens if 8.5 watts per square meter energy is accumulated? Okay, now below these, in the bracket, I have written some ppm numbers. Okay, what are those ppm numbers? If 2.6 watts per square meter should be the radiative forcing, then the amount of carbon dioxide in the atmosphere should be 426 parts per million. Okay. Now, if the RCP value has to increase, then I'm sure all of you will agree the amount of carbon dioxide accumulated in the atmosphere should also increase. Similar. So, if RCP 4.5 has to reach, then 538 ppm carbon dioxide will be there in the atmosphere all the way. If RCP 8.5 is the scenario, that is 8.5 watts per square meter is the forced radiation, then 936 ppm will be the carbon dioxide present in the atmosphere. Okay. Now, one very important thing is what happens if RCP 8.5 scenario is reached. That is, if 8.5, if the carbon dioxide in the atmosphere reaches 936 ppm, resulting in 8.5 watts per square meter, then you can see there at the top, the temperature, the global temperature can rise up to about 3.75 degrees over the average global temperature rise of 15.08. So, the global temperature rise can be close to 4 degrees. Similarly, if it is RCP 6, then the global temperature rise will be more than 2 degrees. If it is RCP 4.5, then the global temperature will be close to 2 degrees. If it is RCP 2.6, then the global temperature will rise by 1 degree by the year 2100. Okay, that is the most important thing. Okay, so again, I'm just reflecting back on this particular slide. What does this slide mean is that neither 8.5 nor 6 nor 4.5 is the solution for us. The only solution for us is RCP 2.6. If we can follow energy consumption pathway, which will ensure that the amount of carbon dioxide emitted in the atmosphere will be maintained at or less than 426 ppm, then the amount of energy accumulated in the atmosphere will be less than 2.6 watts per square meter, and the temperature rise will get limited to 1 degree centigrade by the year 2100, and the human society can withstand the effects of climate change. All other scenarios are ruled out. Okay. Now, this RCP 2.6 is based on what we call as an image model. I will not deliberate much on this. RCP 4.5 is based on what is called as a GCA model. RCP 6 is based on what is called as Asia Pacific Integrated Model, and RCP 8.5 is based on a model called as MESSAGE, which is Model for Energy Supply Strategy, Alternatives, and their General Environmental Impact. So these are 4 different models which have been developed and simulated by different groups. Okay, see, these environmental models are not simple to build and they require extremely high computational power. So what has happened is different groups have taken up the challenge of building different models and then simulating the energy scenario, simulating the climate rise scenario. So four different groups have been created. Each group has taken up building of different models. Okay, now each group has carried out the modeling and simulation based on some of the broad parameters that I'm showing here. It is complex, integrated, and interactive model. Okay, it is pretty complex. It is integrated as well as interactive, and different things are taken into account here. What is the GDP? That is the gross domestic product. What is the population? What are the policies of different governments? What are the other assumptions which are made? How it affects the economy, energy, land use, climate change, etc. Ultimately leading to what is the economic outcome, emission, energy pathway, and land use. So a range of complicated systems are actually involved in this assessment. And here you can see I am showing you an interaction matrix. Can you see this complex integrated interactive model, please?
Yes, sir.
Okay, so here you can see it is so complex. I mean, there are so many variables having effect on each other. So this is a very complicated model that has been built by the 4 different groups under the support of IPCC, and they have come up with this particular graph. Now here you can see the representative concentration pathway analysis graph, and here you can see it starts from the year 1950, goes all the way up to 2200, and what is interesting is by the year 2100. Okay, now The first graph, which is the red graph, is RCP 8.5. That is business as usual. What does that mean? We don't care about climate change. We will continue to make use of energy the way we want. Okay. We will continue to burn fossil fuels. We will continue to use the energy as we want without really being bothered about the climate change. In that case, we call it as what is called as the business as usual scenario. In that case, what will happen is the amount of carbon dioxide that is dumped into the atmosphere will reach 2.1 trillion tons. Okay, 2.1 trillion tons. And the red graph is the pathway. Here you can see, starting from 2000 onwards itself, the temperature rise will continuously take place. Somewhere around 2040, we will cross the 1.2 degree limit, not even 1.5. We will cross 2 degree limit, and by the year 2100, the temperature rise will be close to, it will cross 5 degrees Celsius. What does this mean is, if it crosses 5 degrees centigrade, then there will be no ice in the polar region at all, and there will be only few mountains like Mount Everest, Mount Kilimanjaro, etc., which will be visible. Everything else will go under the water. There was a movie called as Waterworld, where this particular scenario is depicted. Okay, only some of the tallest mountains will be visible. All other land mass will get submerged. Similarly, if you really look at RCP 6.0, which is the brown color line, here again you can see the temperature continuously increases, but the rate of increase will come down. Now, in case of RCP 6, some actions are taken by human beings. Some green energy is introduced, but not sufficient enough to prevent temperature rise from crossing the 1.5 degrees or 2 degrees. Here you can see somewhere in the year 2060 or 2070, the 2 degree centigrade limit is breached. Now, if you take more aggressive approach, then we have RCP 4.5, where the emissions peak somewhere in the year 2040 to 2050, but the initiatives are not good enough for the prevention of crossing the temperature rise of 2 degrees. Okay. Now, this is the next graph, which is the most important one, that is RCP 2.6. So representative concentration pathway 2.6 is what we have to follow, wherein we will limit the carbon dioxide emission into the atmosphere to less than 0.8 trillion tons by the year 2020 itself. So by 2020, we should limit carbon dioxide emission. Somewhere by 2040, the maximum carbon dioxide emission will reach, and then from there, the temperature rise will start decreasing. Okay, it will start decreasing. But here also you can see that we will just cross the 1.5 degree centigrade limit. But then again, by the year 2100, we will come within the 1.5 degree limit. Okay, so the way forward for humanity is the limit of 2.6 watts per square meter emission into the atmosphere. Now, the RCP scenarios told us what will happen if so much of carbon dioxide is emitted into the atmosphere. Different levels of carbon dioxide are emitted into the atmosphere will lead to different levels of radiative forcing, and those radiative forcing will lead to different levels of temperature rise in the atmosphere. Okay. Now, this particular graph shows you what will be the different energy mix if different RCPs are followed. Now, I will draw your attention to RCP 8.5. Here you can see RCP 8.5, coal is maximum. That is, we continue to use energy as usual. But if you come to RCP 2.6, here you can see that bioenergy along with coal are equally prominent. Okay. So what is the major difference between RCP 2.6 and RCP 8.5? The consumption of coal has significantly come down from somewhere about 800 exajoules to 250 exajoules. You can see all yellow lines and compare them with blue lines. All the yellow lines are more or less coming down, and the blue lines are increasing. Okay. blue lines are increasing, especially on the renewable energy front. Okay, that is the most important path. What does this mean? I will again seek your attention to some of the first few slides. Before 1880, humankind was making use of wood as the primary energy source. Now, in the year 2050, again, we have to make use of wood as the primary energy source if we have to survive the climate change. What does that mean? That again means whatever I was talking as the chief guest, saying that Western science has misled us. The only way forward is to again go back to our Indic culture, follow sustainable pathway. Now, the next slide I'm talking here is about technology improvement. Okay, technology improvement is, see, you have your IC engines, gas turbines, so on, so forth. Okay, those IC engines, gas turbines, and so on, so forth have got certain efficiencies today. And here you can see, if the efficiency today has to, if it continues as usual, then we have 8.5 watts per square meter as the radiative forcing. And if the radiative forcing has to come to 2.6 watts per square meter, then you can see the efficiency improvement has to be close to 1.4, 1.5%. Now, the technology has already reached its limit. Further improvement in the conversion efficiencies is not going to be very easy. Okay, but the RCP pathways give us a way ahead to say that even if you can make improvements in the current technologies, there is some hope. We can move from RCP 8.5 all the way to RCP 2.6. Okay, now I am in the closing part of the presentation now. Here we are summarizing the RCP scenario. Okay, on the left hand side you can see the efforts to curb emissions. Okay, for RCP 8.5 you can see we are not doing much in terms of curbing the emissions. For RCP 6 we have done some efforts. For RCP 4.5 our efforts have increased further, but RCP 2.6 you can see we are putting maximum efforts. Okay, lot of efforts we are putting in, and the major change you can see there is energy scenario has moved from coal-powered power plants to primarily renewable energy. And if you really look at transport, the major impact is, instead of having personal mobility solutions, we are going for public transport, electric vehicles and bicycles. Okay, public transport, electrical vehicles and bicycles. Okay, so this is one of the major outcomes of the particular presentation. Now, what is happening is some analysis is being carried out beyond 2100 year also as to what happens if we continue with the current scenario. Okay, so here you can see if we continue as usual by the year from 2100 to 2500, here you can see the radiative forcing can reach 12 watts per square meter, and then in that particular case the temperature rise can be very, very high, and there is no possibility of survival of human beings. Okay, now with this I come to the conclusion of the presentation. Again, make a statement saying that through this presentation, I seek to bring to your attention that we have to give clear or we have to evolve clear understanding towards different energy scenarios from radiative forcing point of view to understand what is their impact on the atmospheric emissions. Okay, we can work on solar energy, wind energy, biomass energy, coal energy, whatever it is, but ultimately we should focus on understanding what is the radiative forcing that it will cause, and in turn what will be the total temperature rise. Based on that we should be able to make careful judicious intervention into the different energy scenarios and different energy sectors. Okay, with this I would like to close my presentation, and I will call for any questions and any clarifications as required, please. Thank you. Over to the organizers.
Thank you, sir. Requesting participants for the questionnaire. From participant side, anyone want to ask the question? You can ask, sir.
Good evening, sir.
Good evening, please.
Sir, we know the new thing that is the hydrogen fuel as a greenery fuel, but as of now, we are coming from new to the topic, sir. That's why I learn from you, sir. Thank you, sir.
Thank you so very much. Thank you. Hydrogen is a very important area and important topic. The
Yes,
most
sir.
important thing that needs to be understood is, in the course of generation of hydrogen, you should ensure that the carbon dioxide emitted will not lead to RCP 8.5 or RCP 4.5 or those kind of scenarios. Okay. So that is the most interesting and most important thing. Hydrogen usage is green, but is hydrogen generation also green is something which is very important, which the scientific community should understand and then take a judicious decision on. That is why we carry out what is called as life cycle analysis.
Yes, sir. Sir, may I know the storage, how to store the hydrogen fuel, sir, for in future purpose?
See, there are different ways of hydrogen storage. One of the simplest way of hydrogen storage is through compression. The next method of hydrogen storage is through metal hydrides. Then we are having hydrogen storage through liquid form. But that is one of the most expensive forms of hydrogen storage. And today, the most promising way of storing hydrogen is convert hydrogen into what are called as liquid organic hydrogen carriers. You convert hydrogen into a different compound for storage and transportation. When you want to reuse it, convert it back into hydrogen. This is called as liquid organic hydrogen carriers, LOCH. LOHC, liquid organic hydrogen carriers.
Okay, sir. Thank you so much, sir.
Thank you.
Hello, sir.
Yes, please.
Yeah. Due to the sea level rise,
Yes, please.
that ocean will capture carbon dioxide because
It's a very
the
good
climate
question.
change.
It's a very good question. It's a very good question. See, the thing is, any liquid absorbing any gas, okay, is a strong function of the temperature. Okay. So now the problem is, as you very correctly point out, while increasing sea level can increase the amount of carbon dioxide that is absorbed by the ocean, the problem is the sea temperature also is increasing. Because the sea temperature is increasing, the carbon dioxide absorption capacity of the ocean itself will decrease and it will give the carbon dioxide back to the atmosphere. So while the sea level rise will take place, it will not lead to proportional increase in the carbon dioxide being absorbed because of the temperature.
Thank you very much, sir. Excellent talk.
Yeah. Thank you. Thank you so much. Any other questions, please?
Hello.
Yes, please.
First of all, thank you so much for this nice session, sir. I am
Thank
Professor
you.
Ayush from GH Raisen University, Amravati.
Hello, Professor Ayush.
Hello, sir. Sir, I would like to ask, we have heard about the hydrogen as a fuel in vehicles.
Yes.
Okay. So, as you have said that it can be compressed for the storage and all, and it can be used for a long duration. So, why this hydrogen fueled vehicle are not implemented yet? What is the reason behind that?
Yeah, it's a very good question. There are two answers for that. See, hydrogen is a very light element. Actually, it is the second lightest element in the periodic table. Compression of hydrogen is very expensive. Okay, and even if you compress the hydrogen, the amount of energy that it carries is very small. See, for example, I'm sure you are conversant with the 200-liter cylinders that we get, typical oxygen cylinders that we guess that you must have seen in hospitals. If you take the same cylinder, put hydrogen in that cylinder, compress it to 200 bar, then you will get only about 600 grams of hydrogen. Okay, you will get only 600 grams of hydrogen. That is the problem. Today in India, we are permitted to compress only up to 350 bars. So 600 can become up to 1 kilogram of hydrogen. Okay, 1 kilogram of hydrogen is equal to only about 2 liters of petrol. Okay, 2 to 2.5 liters of petrol. So now the problem is the mileage. Okay, if you take hydrogen vehicle and if you replace petrol with hydrogen, before you travel 2.5 kilometers, again you have to sit for refilling. Okay, that is one of the major challenges. The second challenge is filling up hydrogen is a time-consuming process. If you want to fill the hydrogen to 350 bar, it will take 10 minutes. Whereas petrol, you will fill it in maybe a minute or so. So that is one of the major challenges. The third challenge is today, even engines and so on and so forth are not really designed for handling hydrogen, which is a completely different fuel, has got very high temperature, adiabatic flame temperature, is having very high flame speed, so on and so forth. So energy conversion is also a challenge. So hydrogen today is being looked at from fuel cell point of view, but fuel cell as a technology is not very mature for deploying on the road. So from hydrogen energy density, hydrogen technology, hydrogen storage, there are challenges across all these three specters, which is resulting in hydrogen vehicles being not adopted widely. It's still in patches.
Okay. Thank you so much, sir. I want to add some more points into this.
Please.
For a can we use the isomers of hydrogen, like the deuterium or tritium, instead of a single atom?
It's a very good question. But then see, the thing is, generation of deuterium or tritium also is a major challenge. Generation of hydrogen is the simplest proposition right now. If you want to generate deuterium or tritium, you should again treat hydrogen. It becomes much more expensive. Okay. Today, if you really look at generation of hydrogen, 1 kg of hydrogen will cost you about 450 rupees. Green hydrogen, I'm telling you. Okay. 1 kg hydrogen, 450 rupees. That means almost 3 rupees 75 paisa for 1 megajoule of energy. Compare it with petrol, you will get 1 megajoule of energy for less than 1.5 rupees. So hydrogen already is expensive. If we move to deuterium or tritium, it becomes much more expensive without any major benefits. So that is why we would prefer to stick to conventional hydrogen.
Okay. It was a very nice explanation. So thank you so much, sir.
Thank you so much. Thank you.
Sure. Yes.
Any other questions, please?
Good evening, sir.
Good evening.
I'm Navya from Vardhaman College of Engineering, Hyderabad, sir.
Yes, please. Good evening.
Can we expect automobiles running with hydrogen in the future, sir, despite of all these disadvantages?
It's a very good question. As a matter of fact, there are two technologies for automobiles which are operating with hydrogen. One is hydrogen in IC engines. The other one is hydrogen in fuel cells. In another 10 years or so, you can see hydrogen operated IC engines. After that, in another 20-25 years, you can see hydrogen operated fuel cells. So yes, in another maybe between 10 to 15 years, you should start seeing hydrogen based automotives on road, please. I'm very optimistic about that.
Thank you, sir.
Yeah.
Any more questions from the participants?
Sir, good evening. I'm Ram Manohar Pandey from Sriram Polytechnic in Bihar. Sir,
Good evening.
I have a confusion. Basically, I don't have question, but I am confused that already we have a variant like we are now going to electro vehicle technology, and electric vehicles are very much sustainable to see and are very much economical, are being proved. And now we are going for hydrogen and clean energy, which is already costly and it is not only costly, but it will take 10 years or 15 years or so for the development of complete technology. So why don't we prefer our electrical technology in vehicles, using vehicles and running all our industrial processes?
It's a very good question and a valid question also, Professor. See, the thing is, while battery is a proven technology, unfortunately, if you do a complete life cycle analysis of battery technology is extremely damaging to environment. Afterlife disposal of battery is a major challenge. Today, it is being handled in a very unsystematic way. People are dumping batteries in ocean. See, because batteries come with a lot of chemicals. So if you do a life cycle analysis, battery technology is the most dangerous dangerous technology for environment. So while battery as an energy conversion system is very useful, well established, but in the long run, it is not a sustainable technology at all. So unless we come up with an appropriate technology to handle the afterlife battery technology will slowly fade away, please. This is the simple reason.
Thank you, sir. Thank you very much.
Thank you.
Hello.
Yes, please.
Good evening, sir. Thanks for this nice presentation, sir. So I have
Thank you. Good evening.
one query regarding what are the geopolitical implications of the global hydrogen economy?
It's a very good, it's a very interesting and good question, Dr. Tanveer. I must appreciate you for asking this question. See, I have written an article regarding this. Okay. Now, I define hydrogen as a secular fuel. Okay. The meaning of secular fuel is everyone will have equal opportunity. Okay. Now today, fossilized fuels are mostly concentrated in certain geographies of the world. For example, your oil is predominantly available in the Gulf and maybe to some extent in Russia. Coal is predominantly available in the Indonesian belt, China and Australia. All other portions of the world are significantly dependent on these regions for their energy needs. But hydrogen per se is not a source of energy, it is only an energy carrier. You have to generate hydrogen either from water or from biomass. This is something which I will make more clear in my next presentation, which will come up on Wednesday. But what I'm telling is either you have to use water or biomass for generation of hydrogen. And here, almost everybody has got equal opportunity in generating hydrogen and hydrogen from either biomass or water. So the way I see it, there will be a greater level of energy independence as we move forward from fossilized resources towards hydrogen. Of course, some companies or some countries which are having technological headway will for some time have additional advantage. But slowly, as we move forward, maybe in another 20-30 years, as all the countries catch up in terms of technology, the energy dependence will significantly come down and the variation in energy prices will be significantly less. I will not say there will be complete independence of energy, but the dependence will be significantly less. These are my 2 cents, please.
Thank you, sir. Any more questions from the participant side?
I think maybe we can now close the session, please.
Yeah, sir.
Yes, sir.
Okay, thank you so very much, Professor Vijay Kumar and all other organizing team members. And thanks all the participating members for patiently hearing to the presentation, and also for some of the wonderful questions that you have posed. Looking forward to seeing you maybe the day after in the second session, please. Thank you so very much. Namaskar and good night.
Thank you, Anand, for delivering an insightful lecture on representative constitutive pathway, global warming potential for primary energy mixes. Sir, your presentation provided us with clear, comprehensive understanding of critical role the energy scenario play in shaping the climate outcome. Once again, thank you for your sharing your valuable knowledge and insight with us. Thank you, sir.